Example 1. Finding maximum volume. Alright, so manufacturer wants to design an open box having a square base and a surface area of 108 square inches as shown in figure 3.53. What dimension will produce box with the maximum volume? So first thing first, you gotta figure out what do they want? Maximum volume. Are you with me, class? So how do you find your volume? Volume is equal to what? The base times what? Height. Are you with me, class? So volume is area of base times what? Height. That's what it is. So my area of a base, what's my area of a base? X times what? X. Is everybody with me? So x squared is my area of a base. What's my height of this? H. Are you with me, class? So now I have a two variable. So that is a problem because I want one equation with only what? One variable, so I know what to do. So that is why I need another equation. So this is what I'm going to do. I need to take derivative of this. Are you with me? Because it says I want to find what? Maximum volume. So that means I gotta take a derivative of a volume to get a V prime. So this is what I want. This is what I want. Okay, now let's see. What do we know? Yes. This base right here. This is x. And that's x. So base is what? X times x. That's a base. That's a rectangle. Rectangle is what? Width times height. Yeah. So right now, this base is your, so this is x times x gives you what? X squared. Does everybody see that? Okay. That's your base. And this right here is your what? Height. Are you following me, class? Okay. All right, so now next thing, we gotta use other information that you give to me. It says the surface area is what? 100 square. So that's the information that you're gonna use to make this equation into one variable. So area of a surface means, what the surface means? You're only looking at the outside. I don't care about the inside. So I need to find the area of a surface. Let's just see what kind of surface we have. Let's draw the surface. We have what? How many of this? I'm gonna draw this. I have a base of a x and height of h. How many of this do I have? One in the front and then what? One in the back. Are you with me, class? So I have two of this. Plus, that's how you find your surface. Surface means you look at each side and the bottom. All right, so what about this? This is what? Also what? X times h. That side, how many do you have? Two. So this is a front and back. This is what? Side, right? Right and left side. All right, what else do I have? Plus. Top, I don't have anything. Looks like to me it's open. Right, so I have a what? Only bottom. What's my bottom? Bottom is x times x. That's my bottom. So only one of them, right? I don't care about the top. Is everybody with me? That is equal to how much? They gave me what? 108. Does everybody see me? So okay, now tell me, can you tell me what this is equation-wise? That's what? That'll be x times what? H. How many of them?
Two.
Two of them, and this is also what? X times h. And what's this one? X squared. That's equal to what? everybody follow me? Did you see how I got this equation? That came from this, which this is x times h, this is x times h, this is what? X squared. So far so good, everybody good? Okay, because I'm about to erase this part so I can solve this equation by one variable. All right. It's asking you what dimension will produce a box with a maximum value. So I need to make this into one variable. Right now I have a two variable. All right, class, is everybody with me? Okay. So does everybody have this picture? Because I need to erase this one so I can solve for h here. Okay. So we have, can I combine these two together? What's that equal to? 4xh, okay. So I know my surface area is 4xh plus what? X squared, that's equal to 108. So I want to solve this one by what you said? H is okay? Okay, so I have 4xh plus x squared equal to 108. And subtract x squared because I don't want x squared, right? So 4xh equal to 108 minus x squared divided by 4x. So h is equal to 108 over 4x minus what? X squared minus 4x. Is everybody following me? Okay. So I'm not gonna do right now, I'm gonna show next page, we'll show you why, then you will know where all this equation came from. All right? So we also having videos, so you can watch those. So remember the problem, chapter 3 graph review problems, it's on the video, so you can watch a YouTube video. Make sure that you watch it and then you understand that, because I told you 80% of your exam come from what?
Yeah.
That one. All right, can I erase now? Because I want to go to next page. All right, you come to next page. So does everybody understand where this came from? Right, the volume? Okay. So we understand that the area of a surface is area base times area of four sides, which we draw a picture for that. So that's why you get this. Is everybody with me? Okay. So I'm gonna rewrite it. So does everybody see how we got this number? Remember we did this one together? Does everybody see that? That's the same thing that we did. Okay. So that's how you get all this. Now what do we do? We're gonna replace H with what? This. Remember we figured out what H is. So I plug in right here. Is everybody with me? All right. So now, does everybody see how they simplify? X times this give you what? Only one X left. And that cancel out. So X times this give you what? All right, we're gonna do which one first? Okay, 108 divided by 4, what's that equal to? 27, is everybody with me? So when you divide it by, so we're gonna do, let's rewrite this problem like this. Is everybody with me? Then you get this is equal to same as x x and x cancel out to go, and then this and this become a what? 27, so you get 27x. And x cancel out, you get only what? X to the third minus what? 4. That's how you get it over here. Is everybody with me? So I didn't skip the step. I expand x squared. Expand this, you get over here. And then you simplify, you get this. Yes.
I was trying to see like the x squared, you know, 4x. How does that work?
This one? How did I get this one? This one?
You know how you at first you did the x squared and that 4 right there? Yeah.
Yeah, this is x squared. H is this.
I know,
Okay.
but I'm trying to see, okay, how did you multiply that to get to 27x? Like when you distribute that
You
x
distribute
squared.
x squared to this, you distribute x squared to where this, and you just simplify. Okay, you know what, class? Let me give you blank paper, then let's do it together. That's probably better, instead of going to the PowerPoint. So, what we know right now, volume is equal to what? X squared times h. We also know surface area is what? 4xh plus x squared, that's equal to what? 108. And we solve this one for what? H. So. Okay, we're gonna solve that for h. We got a what? 4xh plus x squared equal to 108 minus x squared. 4xh equal to 108 minus x squared. Now divided by 4x. So h is equal to what? 100 divided by 4x over x squared over 4x. And let's just simplify it. That becomes 27. That becomes what? Just the x. Is everybody with me? So my h is 27 over x minus what? X over 4. Is everybody with me? All right, now let's substitute it. So now I'm gonna put v is equal to x squared times h. Well, I know what xh is. What's my h? So my h, we just found. What's my h? 27 over x minus what? X over 4. Now let's distribute it. All right, so I'm not skipping any steps, so it's easier for you. So follow this way. So you have x squared times 27 over x minus x squared times x over what? 4. And you're gonna say, okay, I can cancel this one out, just become a what? X. So I have 27x. And you combine those two, you get what? X third over what? 4. Is everybody with me now? So that is my v. So now this is one variable. The v is a variable of what? X. All right. So I can rewrite this one as 27x minus 1 over 4, x to the third. Remember this one? This is, I can just put the coefficient in the front and then put the x in the behind. So I can take power rule. So let's take a prime of that. So if I take a prime, the reason I'm taking a first derivative because it says find me what? Maximum volume. If it's talking about maximum and minimum, you have to take a first derivative and set them equal to 0 and find your critical number. So I have 27, and And this is the same as 1/4 times 3 and x to the what? Second power. Is everybody with me? Taking a derivative of 27x is what? Simply 27. Taking a derivative of this is the same as what? Right here. So I have 27, 3/4 x squared. I'm going to set them equal to what? 0, because I need to find the critical number. Alright, is everybody good? So far so good? Now I'm going to do what then? Divided by 3/4 x squared. Add by 3/4 x squared. So I have 27 is equal to 3/4 x squared. I am looking for x. So I will multiply everything here by 4/3 and over here by what? 4/3. The reason is so I can cancel this one out. You multiply opposite of this. 3/4, what's the inverse of that? 4/3. So 4 and 4 cancel out, 3 and 3 cancel out. Is everybody with me? Are you following me? Okay, so I have here, then you're going to say, oh, this is easy. 3 times 1 is 3. 3 times what gives you 27? 9. So 9 times 4 is what? 36. So 36 is equal to x squared. Then x is equal to what? Plus 6 or minus 6. But I know I cannot use -6. Remember, this is your real dimension. Real dimension doesn't have a negative number. So my answer is only what? This. Because x squared is 36. So x is what? Plus 6 or minus 6? Right, I cannot use negative number because negative number is not a real dimension. Remember, when you talk about dimension, it has to be what? Either 0 or positive number. So, this is what I got. I know this is my critical number, but how am I going to verify this is a maximum? You have to take a second derivative, and you plug this in, and you get what? Negative number as your second derivative, and that's a maximum. But I'm not going to go into that. But I know this is my one of the answer. All right? So I'm not done yet. That's the only x dimension. It's asking you to find the volume of what? Dimensions of that picture, right? So the picture shows this. This is my picture. Picture looks like this. Right? But I know what the dimension is for the base. This is just 6, this is just 6. Do I know what that equal to? Not yet. So what do I need to do? Go back to which one? This, right? H is what? 27 over what? 6. So I'm going to say, okay, I know how to find that. All right, whatever the number is, plug in your calculator, that's your answer then. Let me see, what does it say? The H is equal to 3, yes. So you found it. So your answer is to say what then? Since they're asking you dimensions, so your answer should be what? Then you're gonna say the dimension is what? X is 6 and H is what? 3. That's what you have to say. Then you're done. Class, you need to do this problem by yourself at least a couple times, okay? Because I did it right now with you, so it looks like it's easy because I did it with you, but Do not look at mine. First time, look at what I did and do it.
Mhm.
And the second time, do it without looking at this and see whether you can do it.
Okay.
Or do one more time, just to make sure that you understand, all right? Let me do another example. You want me to erase this one? Is everybody good? Okay. Anyway, this is their guideline. They're telling you what to do. Whenever they give you maximum and minimum problem, this is what you have to do. You need to identify all given quantities and all quantities to be what? Determined. They'll give you enough information to do your work. So you gotta use all the information, okay? Write a primary equation. For our case, the primary equation was value, because it's asking you to find the maximum value. So value was our primary equation. We have another equation. What was that equation? Surface area, right? We're gonna use that to make this primary equation work.
Okay.
So write a primary equation for the quantity that is to be maximized or minimized. Reduce the primary equation to what? One.
Single independent variable.
Right, one variable. That's why we need the secondary equation. Remember, we solved the surface area in terms of what? H equal to something. Determine the feasible domain of a primary equation, like we didn't use -6 because it's a real dimension, which means everything has either 0 or positive number because it's a length. So you need to determine the feasible domain. Determine the desired maximum minimum value of the calculus technique, which we took first derivative. Set them equal to 0 and you find what? Critical number. So this is a technique that you're gonna use always.